Hello everyone, in this video we will take a look at breadth first search. In previous video we have seen depth first search, and before that we have seen how to create the trees in C++. Now we'll see breadth first searches. This is one of the searching algorithm in the trees, applied to the trees. The name itself stands for breadth is first, which means what's adjacent to this, the breadth, which means the same level matters in this one. So we'll see first what is tree, and then how do we create this tree structure, and then we'll write the code for creating trees, and then finally we'll apply the algorithm and we'll see what the output comes here. Okay, now we have seen trees in the previous video also, but here I'm just quick refresh. I'm making you to understand what is tree. Okay, tree is a computer software representation of numbers or data, structured data. There will be a root. Root is the parent top level node, and it does not have any incoming links. There will be only outgoing links. And here the parent node is 1 and the root node is 1. It's parenting to 2 and 4, and here we have 3 as a leaf node which is nothing but it don't have any children underneath this 3. So this 3 5, this 3 5 6 8 and all leaf, and this is child node and this is parent node. Okay, in this graph you can go and click this data and you can check how the tree is formed. I have just imported the same tree in the project, and in this video how do we represent this tree is adjacency list structure. Adjacency list is, I'll tell you this. Here we have a tree. The trees, how it get linked is represented by two numbers. First number is named as u and second number is named as v, which means the u and v. And if we are writing 1 2, there is a link between them from 1 to 2, 1 and 4, 1 to 4. This is a directed graph. Since this arrow mark is there, we didn't route it like 2 to 1. That is different. You can see the sub mark is appearing here, but we don't need that. That's we give it as directed graph. So there will be 1 to 2 and 1 to 4 also there. We just represented tree structure, and with this data how do we form this adjacency list, and with this list we'll construct the tree and then we'll search using breadth first search algorithm in this video. Okay, first I have 1 to 2, then 1 to 4, so I need 1 as in my index here, and I'll add actually this is a kind of array, and here it is a vector. For example, I'll write it in some other code. Switch to eraser. Actually this is called vector. For why we are choosing vector is it's dynamically scaled. Here you can see 2 is there, here 1 is there, here 3 is there, again you have 1. So that's the reason we are keeping it as a vector. Since it's dynamically varies, we are keeping this. Here it is an array, array. So first is column and then array. We have to create a vector of int array. Okay, now 1 is there, we have to add a connection like 1 to 2, 1 to 4, 2 to 3. I just import this data also here. I need one more snippet. Um, what I have is here 1 to 2 is there, so I add 2 here, and 1 to 4 is there, I'll add 1 and 4 here. And then first in this one we are adding 2 more in the first column, so I am first keeping it as an index, then 2 to 3, and next is 4 is there, I'll add 5, 6, 7 at the back by pushing it back to the end. And for 7 is added as an index and 8 is added at the end. Okay, now we have this structure, so how do we make it in the code? So we just switch back to the IDE and we'll code the structure and we'll make this adjacency list, and then we'll see what its purpose searches. Now my compiler is ready, and one more time I'm running the code and checking whether it's working fine or not. Yes, it successfully print that hello world. In this sample snippet, I have just a hash include IO stream and using namespace standard, and I declare just int main and cout and return 0. So first I need to declare is count. How many nodes will be there? So in my tree there are 8 nodes. 1, 2, 3, 4, 5, 6, and 8. 8 are there. So I just need a number to track that. So I'm giving count, and I'm getting that count also. In tree there are n minus 1 edges will be there. For any tree, if 8 nodes are there, there will be n minus 1, which means 7 nodes will be there. So 7 edges will be there. You can count this like 1, 2, 3, 4, 5, 6, and 7. If we add one more edge, that will become a graph. For example, here you have this 7 to 5. If you are adding, this is not a tree because you can see in this one it's forms a cycle, so it's not become a tree, it will be a graph. So n minus 1 edges. So what I'm doing is, for the next line I have to retrieve this array I must retrieve. So what I'm doing is for loop of int, then I'm giving count minus 1, and the first thing I have retrieved is u and second is v. So I need variables for those, and I'm writing u and v, u and v, then colon. Okay, now you need this vector I told as used as adjacency list and a vector of int I. So what I'm going to do is I just import hash include vector. Here I'm declaring it as vector of int and adjacency array. Here you need to declare what's the size. I told this index rows as index. There how many number of entries are possible, you have to declare. For approximation I'm giving 1 million entries, so 1 e power 6, and I'm declaring it as integer type, casting it as integer type. Now I have to push back these u and v to this. I told you to that first number will treat as index and second number will treat it as a value. So I just add it as adg of u dot pushback v. Okay, now we pushed back and we prepared this array. Now we have to visualize this, we have to traverse in this. So what I'm doing is I'm going to use this algorithm called breadth first search algorithm. Now just let me explain how do we get the output, and then we'll move back there, and what's inside happens we'll explain with the help of Q. This one, I'm just clearing everything. Okay, now all are cleared up. Okay, now what the algorithm is, breadth first search. We have to take the breadth, which means which is in the same level we have to take. So what I'm taking is, first I'll take the root node. Um, Let me erase this also. We'll use some other. First we'll take the root node and we'll add it. We will get the what the child attached to it. So what the child attached to it is 2. So we'll get this child and we'll just print it, and we'll see what and all child attached to it. We'll add the end of the queue. So what my output stands for, what the output will come, we'll see. So first I'm taking 1, so 1 supposed to come, and then next is we'll add it in the queue. So here 1 will come. So I'm iterating what the first child is, then 2 is added to the queue, and I'm printing this 1. So we have to pop it up and we delete it. So it's transferred to 2. It's like it's just going in front of it. We'll delete the first one in the queue and we'll add it to the end as a new number. The next upcoming numbers we'll add at the end. So 2 is added, and then what the remaining child we have is 4. So 4 also is added. So the actual numbers attached to 1 is over. So first I'm taking out 2. So 2 we are taking out, and then we are printing it. So I'm seeing what and all attached to this 2. So 3 is attached to here. So I'm adding 3 at the end, and that's it. 3, we don't have any other number here with 2. Here you can mark this as from 2, we'll from this one we'll took 4, and here we took 3. After 2 is taken, we added the 3 at the end, and then we have, just think of this cell is no more valid. We'll switch that to white. Now this is the front of the queue, and we'll pop this queue out, and we'll add this 4. And then with 4, when I'm taking, I'm seeing how many numbers are attached to it. There are 5, 6 and 7. So I'll add this 5, 6 and 7, and I'm deleting this first because we printed, it's no more needed. And then now I'm taking 3. I'm seeing any 3 is there or not. There nothing is there, so I'm printing that also. And I'm taking 5. 5, anything attached to this 5? No. And I'm printing this and deleting it. I'm taking 6. I'm seeing anything attached to it. Nothing is there in the tree, so I'm printing 6 and deleting this. I'm taking 7. If I'm seeing anything attached to it, yes, something is attached, so I'm adding and deleting at the front. So I'm printing here. And 8, I'm seeing anything attached to it, nothing is there, and then I print 8. Okay, this is the output we got. This same thing we have to implement with the help of Q in the code. This is what the breadth first search algorithm is. Okay, I'm one more time I'm repeating, not much. First we'll take 1 and we'll see how many childs are attached to it. So 1 is there. First we'll insert 1, and then we'll take that out and print it, and we'll see what are all attached to it. We'll add 2 and 4, and we'll 2 will take 2 and then we'll see what and all attached to 2. We have 3 there, so we attach 3 at the queue, and the next number will take 4, we'll print it, and we see what and all attached to it, 567, so we'll add 567, 5 6 and 7. Now we'll print the 4, and we'll delete it, and then we'll see what the next number is. Next number is 3. We'll see anything attached to it, nothing, so we'll just delete, print and delete it. Next 5, nothing is there, so I'll print and delete it. Next is 6, nothing is there, I'll print and delete it. And 7 is there, some number is there, so I'll add it. And I print it, I delete it. Now 8 is there, I print it and delete this number. It's okay, now queue is empty. We have to continue this task until the queue is empty. So the same thing we'll implement in code. Okay. Okay, I just created the adjacency list, and I am creating one more function called breadth first search. Here I'm passing the same this adjacency list as a parameter, so I need the same return type. What I'm doing is vector int adj and brace, and I need a root. Here 1 is the root. We have to pass this 1 as root, because here we have take consideration of 1 as a rooted tree. Okay, I have to pass it as root. Here return 0, because we need to return something. In this one, what the queue is, here as a C++ developer, you have to use the list. So there is queues are there, but you can go with list, because list provides a lot of options. You can import the list. You can name it as list of int as queue. Okay. First initial level element, we'll add it. So what we did in this one is, first we by default we just added this one in the queue. So same thing, I have to add it here. So queue dot, here we have pushback option, pushback queue pushback the root, and for each element attached to this, which means 2 and 4, we are included in this one. So we have, first of all, we have to add it in the queue, so we did it, and we have to continue this task until the queue is not empty. So what I'm doing is queue dot empty. Empty will check. Here you can see it is a boolean. It will check and tell you whether the queue nothing is there or anything is there in this. Okay, first we have to see at front what's there in this queue. So what at front means, the first element what it is. So I'm going and taking int front equal to queue dot front. I'm using. Okay, now with this front, I have to see, with this one I have to see what and all attached to this, which means I'm going here to this one. From this one I'm going to this adjacency list, and I'm referring what and all attached to it. So if I'm giving 1, it should gives me 2 and 4. So for we have to use some advanced for loop. Here I'm changing the type as int and I'm giving it as u type, and in adjacency matrix I have to find front, and this will give 2 and 4 like that. So what I'm doing is how to insert it in the queue. So I'm using pushback. So queue dot pushback. Here I have to push back. But before adding to the queue, you know that we have printed in the output, which means we removed unprinted. So what I'm doing is I remove it. Which you have to use pop back. So pop front, pop, because in front only we are removing. We are removing at the front, and we are adding at the end. Uh, we are removing here and adding at the end here. So I popped it and I took the reference number in the front variable and I can use it further. And here I can write cout front indel. Okay, here you can give cout BFS output is indel, and before that, after that you have to call that breadth first search, and you have to pass this ADJ as a reference and one as root. Okay, we have to continue this task until the queue is empty. I hope the code is fully written. We have to declare the queue, we have to push that root, and we have to continue the task until it's not empty. First we have to pop up, first we have to get the front, and we have to pop it and print it, and we'll see what are all in the queue, and it continues like that. Okay, until it's getting empty, until it's not empty. Okay, now we run the code. We have this sample data. What this tree representation is, I have this as a sample data. Now run it. I cleared the data, so I copy this one more time and saving the code, and right click, run the code, paste the data. Here we got this output 1 2 4 3 5 6 7 8. So here 1 2 4 3 5 6 7 8. Okay, we achieved the output. You can copy this numbers and check it there. 1 2 4 3 1 2 4 3 5 6 7 8. Yeah, we got it. Okay, this is the actual functionality how breadth first search works. Hope this video is helpful. And breadth first search is the most frequently used, one of the most frequently used algorithms in the programming. Okay, and we'll see in the next video. Thank you for watching.